All right, this is Math 2, Unit 9, Worksheet 1. We're going to go over numbers 18 through 27. In these problems, we're going to be multiplying monomials and polynomials. And I'm Mr. Trutna, and currently we are at Clovis High School. So this is the worksheet right here. We're going to start at number 18, and we're going to finish at number 27. So in each problem, notice that the instructions say to simplify each product. Okay, so the word product means that we're going to be multiplying. That's what the word product means in math. And then simplify means that we are going to be writing our answer in the simplest possible form we can. Okay, so in number 18, we're taking the monomial 3w, and then we're going to multiply it by the binomial, which is w plus 2. So the process that we're going to use for this is the distributive property. Okay, so we're going to take the outside term, which is 3w, and we are going to have to distribute it into every term that's inside the grouping symbol, the parentheses. So we're going to have to go 3w times w, and then we're also going to have to go 3w times positive 2. Okay, and then we're going to write out what we get. So 3w times w, remember these w's have an exponent of 1. It's implied that it's a 1 if the exponent is not shown. So when we multiply those together, we get 3w to the second power. You add the exponents when you're multiplying of expressions that have the same base. And then we're going to go 3w times 2, and that's a positive 6w. So I would write that. Okay, now that right there is my simplified expression. Because I cannot add 6w to 3w squared, that's all that I'm doing in number 18. Okay, number 19 is the same exact concept, except for, if you notice, the monomial that we're distributing is, instead of being in front of the parentheses, it's on the back. Okay, you do it the same way. So you're going to take this 2z, you're going to multiply it by that z, and then you're going to take this 2z and you're going to multiply it by the positive 5. Okay, write down what the results are. 2z times z. Once again, these have exponents of 1, so that would be 2z to the second power. 2z times 5 is positive 10z, so I have to write plus 10z, and that's my simplified expression because I cannot add 10z to 2z squared. Okay. Number 20, I'm going to take the monomial, the outside term, and I'm going to distribute. So we're going to go 3m to the second power. We're going to multiply it by 4. That's going to give me a result of 12m to the second power. And then I have to distribute the 3m to the second power times the positive, or multiplied by the positive m. Okay, so 3m to the second multiplied by positive m. Once again, that m has an exponent of 1, so that would be a positive 3m to the third power. Okay, now, I cannot add 3m to the third power to 12m squared, so that is my simplified version. But remember, we want to write our answer in standard form. Standard form meaning that when I have exponents, I always write my exponents from largest degree exponent down to smallest degree exponent. Okay, turning the paper over, number 21. Now if you notice in number 21, I'm taking my monomial, 2p, but now I have to multiply it into a trinomial, p squared minus 6p plus 1. This just means that I'm going to have to distribute the 2p 3 separate times. Okay, so I'm going to have to go take the 2p, I'm going to have to multiply it by the p squared, then I'm going to take the 2p, and I'm going to multiply it by, now the 6p I have to treat as negative, so it's going to be a negative 6p. And then thirdly, I'm going to take the 2p and I'm going to multiply it by the positive 1. Okay, then I'm going to write out my results. So that p has an exponent of 1. So 2p times p to the second is 2p to the third. We add the exponents up. Then we're going to multiply this expression out. Okay, 2 times negative 6 is negative 12, so I'm going to have a minus 12. And then p to the first times p to the first is p to the second. So that would be negative or minus 12p squared. And then 2p times positive 1 is positive 2p. Okay, now, you cannot subtract 12p squared from 2p to the third. You cannot add 2p to 12p to the second. So this would be my simplified expression. Notice that the exponents are written from highest degree down to smallest degree. 3, 2, and that would be a 1. Number 22, I'm distributing the negative y. So we're going to go negative y times 5y to the third. Then we're going to go negative y times negative 3y to the second. And since that 3y to the second has a minus sign in front of it, we have to treat it as negative. Then we're going to distribute the negative y, multiply it by the positive 2y. We're going to write down our result of each multiplication process. Okay, so a negative y, that's like a negative 1 times 5, that's negative 5. And then y to the first times y to the third is y to the fourth. Okay, moving on to this term, a negative y, that's like a negative 1 times a negative 3, that's going to be a positive 3. Y to the first times y to the second is y to the third. And then the last part, the negative 1y, so negative 1 times positive 2, that's negative 2. Then y to the first times y to the first is y to the second. That is my expression. I cannot combine any of those together, and it's written in standard form from highest degree exponent on down. Number 23, now we're going to distribute the 3a. So we're going to go 3a and we're going to multiply it by negative 3a squared. So 3a times negative 3a squared. Then we're going to multiply the 3a times the positive 2a, and we'll write that result underneath it. And then we're going to distribute the 3a times the 7, but we have to treat it as a negative 7 because that 7 has a minus sign in front of it. Okay, multiplying each of the expressions out, I'm going to end up with 3 expressions. 3 times negative 3, multiplying the coefficients, I get negative 9. A to the 1 times a to the 2 is a to the third power. Moving over here, positive 3 times positive 2 is positive 6, so I write plus 6. A to the 1 times a to the 1 is a to the second power. Last part, 3 times negative 7, I multiply the coefficients. That would give me a negative 21, so I write minus 21, and then I have an a. Then you can see I cannot simplify this expression anymore, because although each term has an a in it, because the exponents are different, that means I cannot combine them. Okay, number 24. Now I'm going to distribute the 6x to the third. So I'm going to go 6x to the third. I'm going to multiply it by 3x to the second. Then I'm going to go 6x to the third. I'm going to multiply it by a negative x. I have to treat that x as a negative x. And then lastly, I'm going to take the 6x to the third and I'm going to multiply it by the positive 10. And then I'm going to write out each result underneath it, so I'm going to end up with 3 terms. Okay, 6 times 3 is 18. X to the third times x to the second is x to the fifth. Then I'm going to go 6 times, now this x has a coefficient of negative 1, so that would give me negative 6, so I write minus 6, x to the third times x. Once again, that x has an exponent of 1, so that's x to the fourth, negative 6x to the fourth. 6 times 10 is positive 60, and then I have an x to the third, and that is my simplified expression. I cannot combine, even though every term has an x in it, because the exponents are not the same. That means they're unlike terms. So there's my answer. Okay, 25, I'm distributing the negative 4h. So I'm going to go negative 4h. I'm going to multiply it by negative h to the third. Then I'm going to distribute the negative 4h into the negative 8h squared. So negative 4h is going to be multiplied by negative 8h squared. And then we're going to multiply negative 4 times positive 2h. Negative 4h, sorry, times positive 2h. So now I'm going to write each expression below it. Okay, negative 4 times negative 1, that's like a negative 1 there. That's going to give me positive 4. h to the first times h to the third is h to the fourth. Moving over to the next expression, negative 4 times negative 8, that's positive 32, so I put plus 32. H to the first times h to the second is h to the third. The last expression, negative 4 times positive 2 is negative 8, so I put a minus. H to the first times h to the first is h to the second. Now you can see every expression has an h in it, but the exponents are not the same, so that means we cannot combine. That means this is my simplified version. And it's in standard form because I'm going from highest degree exponent on down. Number 26, I'm distributing the 4h, or 4n, so I'm going to go 4n times n squared for my first term. My second term, I'm going to multiply 4n times positive 5n. And for my third term, I'm going to multiply 4n times positive 6. So I'm using the distributive property. That 4 has nothing to multiply by it, so I'm going to have a 4. N to the first times n to the second gives me 4n to the third. Multiplying the second terms together, 4 times 5 is positive 20, so I write plus 20. N times n is n to the second. Multiplying the third terms, 4 times 6 is positive 24, and then I have an n. So that would be my simplified expression to number 26, and I cannot combine any of them because although they have the same variable n's, each variable does not have the same exponent. Okay, number 27, it says the perimeter of the triangular, this is a triangular park, I guess. So here's my park right here. Okay, and then the perimeter is 16x plus 3, and it says what is the missing length. So if you notice, this length right here, we do not have. Okay, well, what do I know in this problem? I know that my perimeter is equal to 16x plus 3. Okay, well, this is the key. How do you find perimeter of a shape? You add up all the sides. So that means if I take the bottom side of the triangle, 2x plus 5, I add it to this side, 5x minus 1, and then I add it to this missing piece, which I have no clue what it is right now, so I'm just going to put that symbol there. And then we know, though, that the perimeter of the park is 16x plus 3, so we know that when I add everything together over here on the left of the equation, I have to get a solution of 16x plus 3. Okay, so now I'm just going to see what happens, and I'm going to work this out. So if you notice, I have a 2x here, and I have a plus 5x. So I can combine those two together, and that gives me a 7x. Then if you notice, I have a constant, a positive 5, and a constant, a minus 1. So I could add those together. Positive 5 minus 1 gives me positive 4. So if I combine the two values that I know, I get 7x plus 4. And I know that if I add it to whatever is going to go in there, that has to be equal to 16x plus 3. So what I'm going to do is I'm going to solve this equation for this symbol here. So I'm going to subtract 7x from both sides of the equation. And at the same time, I'm also going to subtract 4 from both sides of the equation. Now, what does that do for me? It cancels out these values. And then it's left with this. And if you notice, that symbol is equal to 16x minus 7x is 9x. And positive 3 minus 4 is negative 1. And that's my symbol. So it says, what is the missing length? Well, my missing length is 9x minus 1. Okay? And that's for the worksheet there. Use this to check your answers. Use this to watch the work being done if you're not sure how to do it. But be well and do math good.